So I'm Gildo Andreoni from Data Sensing, and so now we are going to talk about three components of the RS4 of Rossini, which are the RS4 Controller, the RS4 Vision, and the RS4 Laser. This is the architecture that Ricardo showed before, and the RS4 components, that RS4 stands for Rossini Smart and Safe Sensing Systems, are developed inside the work package 3 of the project. And the main aim is to combine a set of sensors that can be also from different technologies in order to reconstruct a monitored area using a sensor fusion. And the reconstructed environment will be used to limit the speed, for example, of the robot, or stop the robot when an hazardous situation can occur for the human. The information generated by the safety sensor could also be shared with another layer, which is the outside layer in this image, that can take advantage of the fused information to generate better trajectories for the robot, for a task accomplishment, or for maximize the behavior of the robot. So this is the connection diagram, I would say, and on the right we have the RS4 System controller, which is a component that is in charge of collecting the data from different kinds of sensor. For example, on the left we have the RS4 Vision sensor, which are 3D cameras that we developed from scratch in the project in data sensing, and can be connected up to 4 to the RS4 system. And also the data coming from multiple laser scanner, up to 4 laser scanner, can be acquired by the RS4 system. This RS4 system controller can be connected to the robot in a safe way to limit or stop the robot when hazardous situation occur for the human. Also, other sensor can be connected that are the one described by Matthias before, that are the RS4 skin and the RS4 radar, but are not part of this presentation. So the safety in collaborative robotics. Basically, what we implemented in our controller are some of the modalities that are described in the ISO TS 15066 that describe the safety function of the robot that can be collaborative or not. So the first one is the simplest one, and is a safety rated monitor stop. Basically, what happened is that when a human enter in a forbidden zone, the robot will be stopped to ensure the safety of the human. A more advanced modality is the speed and separation monitoring. That is the one that we can use for change the robot speed according to the distance between the human and the robot, to ensure that a collision will never happen between the human and the robot, because we have time to stop the robot in time. And another modality that we can use is the power and force limiting. So this one can be used, for example, if we have a collaborative robot. So we have the ability to switch the robot in a collaborative mode. In that case, a collision is can happen, but will not be hazardous for the human, basically, because the force is limited. So this is the behavior that we have implemented. So in the diagrams on the right, we have on the x-axis the distance between human and robot, and in the y we have the maximum speed allowed for the robot. So as we can see, higher is the distance and higher is the maximum allowed speed. But the behavior that we have that we can implement if we have a non-collaborative robot is different than the one that we can implement if we have a collaborative robot. For the non-collaborative robot, there is a threshold distance, I would say, that actually says under this distance between the human and the robot, you have to stop the robot. So go to a safety rated monitor stop. Over this distance, you can increase the speed of the robot depending on the distance between the human and the robot. On the other side, with a collaborative robot, under that threshold distance, we can switch the robot to a power and force limiting mode. So we can allow the robot to still move, also if lower speed and with lower force, until the touch occur between the human and the robot. So about the minimum distance calculation approach that we have. So it's pretty different from the one that is used by the safety sensor on the market, because currently, actually, the minimum distance that we need to take into consideration is the one defined from the human to the reach of the robot, so which is larger of the volume occupied by the robot. So this give you a lower minimum distance between human and robot, and so a lower allowed speed. With RS4, the approach that we are trying to use is to measure both the position of the human and the robot, and so time at runtime. So we will have a lower minimum distance and a higher maximum allowed speed. So the first technology that we have developed is this RS4 Laser. So it's based on the data sensing safety laser scanner, and we created it fusing multiple data coming from multiple laser scanner, up to 4 laser scanner. In this way, we can reconstruct a 2D map of the environment. And in this case, on the left, we can see a video of a human, for example, working on the monitored area. And in this way, fusing multiple devices, we can solve the occlusion that can happen, if, for example, if an object is placed on the scene. Another device that we developed, which is probably the one that requires more effort, is the RS4 Vision. So those are 3D cameras that can be placed in the working environment, also more than one, so up to 4, in order to enlarge the monitored area or to resolve the occlusion that could occur. So this is these devices is developed taking into account the ESC 61496 that actually describe how to create a 3D camera to be safety compliant. In the image, we can see that so the robot is recognized as a robot and labeled with the purple color, and the human is recognized as human and labeled as with blue color. And the minimum distance that is measured is the line that we see in the image. And what about the RS4 system? So the RS4 controller. So is the component that can collect the data from different kind of sensor, multiple sensor, and fuse it together in a single map. So on the right, we see, for example, the dots on the floor, which are the 2D map reconstructed by the RS4 laser, and is placed in the same scene of the 3D point cloud generated with 3D cameras, so the RS4 Vision. And in this way, we can define the behavior of the cell using multiple kind of information. And here in the RS4 system is where we have implemented the speed and separation monitoring, the safety rated monitor stop, and other advanced functionalities. And this component can be interfaced with the robot using a safe interface, and the generated data, so the processed data that we can see on the right, but also the raw sensor data can be shared with a second controller, which is not safety related, and can use this information for example, for AI or object recognition or other tasks that are not safety related, but useful for define the behavior of the cell. So I guess that's all. Thank you very much.